In this video, I will show you how to find missing sides and angles on a right triangle using sine, cosine, and tangent. Now, these are the definitions of sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We can abbreviate those three definitions using one word, SOHCAHTOA. So I'm going to show you how to use SOHCAHTOA to find missing sides and missing angles on a right triangle. So let's dive in. In fact, I think I will just write down the word SOHCAHTOA here at the top. All right, obviously that stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we'll just use that to keep it in the back of our minds. The first thing you should do is label the hypotenuse, which is right here. Next, you should circle the angle that you're dealing with. Draw an arrow away from it. That will point right at the opposite side. The other side is the adjacent side. Next, ask yourself which sides you have. Okay, we have opposite and hypotenuse. Those are the two sides that we have, opposite and hypotenuse. So which trig function is that? Sine is opposite over hypotenuse. So this is the one that we're going to end up using. So we will start off writing sine. Next comes the angle, the one that we circled. In this case, it's an x. So sine of x is equal to opposite over hypotenuse. So that is 58 over 64. Now, when the variable is inside the trig function, this is when you do the inverse. So we're going to do the inverse sine of 58 over 64, and that should equal x. Basically, these two things switch places, and it becomes the inverse sine. And this is just a calculator thing, so 58 over 64. So there's sine. If we do second sine, it's inverse sine of 58 over 64. And this gives us the angle, so 64.992. All right, so that is the answer for problem number 1. Let's keep practicing. All right, so problem number 2, let's get ready. SOHCAHTOA. So where's the hypotenuse? The hypotenuse is always across from the 90-degree angle. The corner of the box is always pointing right at the hypotenuse. So this is the hypotenuse right here. Next, circle the angle that you are dealing with. Draw an arrow going away from it. That will indicate the opposite side. The other side is the adjacent side. Now, which two sides are we dealing with? Well, we've got adjacent is 64, and the hypotenuse is the x. So adjacent and hypotenuse. Which function is that? Well, that is cosine. Cosine is adjacent over hypotenuse. So we will start by writing cosine of the angle that we circled. So cosine of 58 is equal to adjacent over hypotenuse. So 64 over x. When the variable is in the denominator, that is when you swap these. Okay, so the x is going to end up over here, and the cosine of 58 is going to end up over there. So to the calculator, 64 over cosine 58. So 64 over cosine 58. So that is 120 0.773. All right, let's head over to problem number 3. Okay, SOHCAHTOA. Start with the hypotenuse, which is always across from the 90-degree angle. So this is the hypotenuse. Next, circle the angle and draw an arrow going away from it, and that will be the opposite side. The other side is the adjacent side. So what are the two sides we're dealing with? Well, x is opposite, 64 is adjacent. Nothing's going on at the hypotenuse, so it's just opposite, adjacent. Which trig function is that? Well, tangent is opposite over adjacent. So let's start off by writing tangent of the angle that we circled, which is 58, opposite over adjacent, so that's x over 64. When the variable is in the numerator, that is when you multiply both sides by the denominator. That way these cancel each other out. So that will get x by itself. So 64 tangent 58. 102.421. All right, let's try number 4. All right, let's get our SOHCAHTOA ready. All right, start with the hypotenuse, which is always across from the 90-degree angle, so that means this is the hypotenuse right here. Next, circle the angle that you are dealing with and draw an arrow going away from it. That arrow will always point at the opposite side. The other side is the adjacent side. So, which two sides are we dealing with? Well, 37 is opposite and x is adjacent. Opposite, adjacent. Which trig function is that? Well, that is the tangent function that involves opposite and adjacent. So we will start by writing down tangent of the angle, all right? Never just write tangent, you have to put the angle, so tangent 40 is equal to opposite over adjacent, so 37 over x. Okay, when the variable is in the denominator, that is when you swap. So we will do x is equal to 37 over tangent of 40. And then you just put that in your calculator. So that's 44.095. Got to round up. 44.095. Okay, how about number 5? Okay, let's get that SOHCAHTOA ready. All right, where is the hypotenuse? It is always across from the 90-degree angle. So this is the hypotenuse. Next, circle the angle that you are given and draw an arrow going away from it. This will point at the opposite side. The other side is the adjacent side. Now, which two sides are we dealing with? Well, x is opposite and 37 is hypotenuse. Which trig function involves opposite and hypotenuse? That is the sine function. So we will write down sine, and then comes the angle that we circled, which will be 40, is equal to opposite over hypotenuse. So that's going to be x over 37. When the variable is in the numerator, that is when you multiply both sides by the denominator. So these will cancel each other out. And that will lead you straight to your final answer. X is by itself now. So 37 sine 40. $23.783. All right, is that what I said? Okay, all right, on to number 6. All right, so, ka, toa. Where is that hypotenuse? It is across from the 90-degree angle, so this is the hypotenuse. Circle the angle that you are dealing with. So that's the angle. Even though it's a variable, I circle it and draw an arrow going away from it. That will point at the opposite side. The remaining side is the adjacent side. So which two sides am I dealing with? I've got 37 is adjacent, 40 is hypotenuse. Which function involves adjacent and hypotenuse? Well, that looks like the cosine function. So we will start by writing cosine of the angle that we circled, even if it's a variable. So cosine of x is adjacent over hypotenuse. So that's 37 over 40. When the variable is inside the trig function, that's when you have to do the inverse. So we will do inverse cosine, and then we basically reverse these. So it'll be inverse cosine of 37 over 40 equals x. So this goes in your calculator. Okay, so inverse cosine of 37 over 40. And that's 22.332. Got to round up. 22.332. All right, so that's how you find that missing angle. Okay, how about number 7? All right, so ka toa. All right, where's the hypotenuse? It's always across from the 90-degree angle. So that means this is the hypotenuse right here. Next, circle the angle that you are given, draw an arrow pointing away from it, and that will always tell you the opposite side. The remaining side is the adjacent side. So, which two sides are we dealing with? Well, x is adjacent and 17 is hypotenuse. Adjacent and hypotenuse. Which trig function involves adjacent and hypotenuse? That is the cosine function. So we will write cosine of the angle that we circled, which is 54, is equal to adjacent over hypotenuse. That's x over 17. When the variable is in the numerator, that is when you multiply by the denominator. That way, these will cancel out and leave x by itself. And that will lead you straight to the answer. So in your calculator, we will do 17 cosine 54. So that's 9.992. All right, that's number 7. All right, number 8. All right, let's get ready with SOHCAHTOA. All right, where's the hypotenuse? It is always across from the 90-degree angle, so this is the hypotenuse. Next, circle the angle that you are dealing with, even if it is a variable. Draw an arrow going away from it, and that will point to the opposite side. The other side is the adjacent side. Now, which two sides are we dealing with? Well, 54 is opposite and 17 is adjacent. Which trig function involves opposite and adjacent? That is the tangent function. So we should start by writing tangent. Tangent of the angle that you circled, even if it is a variable. Tangent equals opposite over adjacent. So that is 54 over 17. When the variable is inside the trig function, that's when you do the inverse. So we will do inverse tangent. Inverse tangent of 54 over 17 is equal to x. Okay, these switch places. All right, and this becomes a calculator thing. So inverse tangent of 54 over 17. $72.525. All right, how about number 9? All right, let's get ready with our SOHCAHTOA. All right, got to spell SOHCAHTOA right. Where is the hypotenuse is the first question. Always across from the 90-degree angle. So here is the hypotenuse. Always label that first. Next, circle the angle that you are given. Draw an arrow going away from it. That will tell you which side is the opposite side. The remaining side is adjacent. Now, what are the two sides we are dealing with? 17 is opposite and x is hypotenuse. Which trig function involves opposite and hypotenuse? Well, that's the sine function. Sine is opposite over hypotenuse. So we will start by writing sine. Next comes the angle, which is, in this case, is 54. So sine 54 is equal to opposite over hypotenuse. So that's going to be 17 over x. So is this the one where we multiply? Is this the one where we swap? Or is this the one where we do the inverse? Well, when the variable is in the denominator, this is when you swap. Okay, so if I swap these, then I'm going to get x over here, and then I'll have 17 over sine 54. And that becomes a calculator thing. (17 over sine 54). That's 21.013. So that is how you use sine, cosine, and tangent to find missing sides and missing angles.